Good evening, and welcome back to our conversation about designing our experiments and things that we want to make sure that we keep in mind as we go forward with setting these guys up. So far we've talked about the difference between an experiment and an observational study. Experiment, we're actually imposing a treatment, and that's the only way we're going to really be able to establish cause and effect. If one thing causes another, is if we actually perform an experiment. And then we talked about how to best do that. We want to make sure that we're considering lurking variables and making sure that they're not driving our responses instead of our explanatory variables, or the things that we want to measure. So some things we want to make sure we do and keep in mind is we want to make sure we randomly assign our subjects the same as we wanted to randomly sample from our population for our surveys, right? We want to make sure that we're using random chance to split up our subjects and not introduce any kind of bias in doing that. And then as far as replication is concerned, we want to make sure that we're using enough subjects that even when we randomly assign our subjects, that we're not creating two groups that are different in some systematic way, even by random chance. And so we make sure that we're using enough to reduce the likelihood of that happening. And then control, we want to make sure that we have a baseline comparison, some sort of comparison group to our treatment group. That control group could receive an inactive treatment. It could just receive a different treatment and serve as a control group. But we want to make sure that we have some way to compare our actual treatment to. And so, we talked a little bit about those aspects in this aspirin and beta carotene study with the Physicians Health Study. And we introduced a term called placebo. We want to make sure we talk a little bit more about that in terms of our control group. If we're going to run a control group, then we have to make sure that we're treating the control group the same way we do the treatment group, so that they can't either consciously or unconsciously, sorry, you can't do anything unconsciously, consciously or subconsciously, do things that are going to influence the outcome of a study other than the treatment. So anyway, to do that, we can introduce what's called a placebo. So the reason why we do that is because, again, we want to make sure that we're treating all our subjects the same in every way except for the actual treatment. So we want to make sure that our groups are equal, or have the same makeup. And so we're going to make sure that we consider all of the details in going through and designing our experiment. Because if we're not careful, we can get to a situation where we have a placebo effect, which is a response to a dummy treatment. Kind of like when my 3-year-old falls down and scrapes her knee, she starts crying because it hurts. And then, of course, what do you do as a good father or a good mother? You bend down and kiss her boo-boo, and when you do, it's automatically healed, and she's just fine. She stops crying, right? Obviously, my kisses don't hold any magical properties that I know of that can heal any wounds. So she's obviously experiencing the placebo effect. And the placebo effect can be pretty strong. But we have to make sure that we account for that. And so how do we account for that? Well, whenever possible, we're going to try to make sure that our experiments, especially with human subjects, are double-blind. And so in a double-blind experiment, neither the subjects nor those that they interact with or anyone measuring the response know which treatment a subject receives, right? So we want to try to make sure that we blind our experiments, double blind preferably, so that neither the subjects nor the people measuring the response know which treatment was received. But sometimes it's not possible, right? If I want to know whether a good, healthy, balanced diet or exercise will help reduce weight, will help you lose weight, then you can't impose that treatment, either a diet or exercise, without the subjects knowing. And so you have to single blind, but when possible, we do want to make sure that we double blind, okay? And if we don't, then our data becomes a lot less reliable. And so a situation like that might look something to the effect of the Check Your Understanding on page 244, okay? Take a look at that real quick, read through that. I'll bring that up here for you in case you don't have your book in front of you. Write out your responses to this and really think about the situation and what might occur given the way that the experiment is set up. So take a couple seconds, write those responses out, stop the video, and I'll show you what I came up with, and we can compare results. Okay, so what did you come up with? So we're looking at this. In an interesting experiment, researchers examined the effect of ultrasound on birth weight. Pregnant women participating in the study were randomly assigned to one of two groups. The first group of women received an ultrasound. The second group did not. When the subjects' babies were born, their birth weights were recorded. The women who received the ultrasounds had heavier babies. Okay? Interesting. And again, footnote alert, this study actually took place. And I'm sure the setup and the results are outlined in a little bit more detail in a journal somewhere. Okay? But anyway, what we want to take a look at, did the experimental design take the placebo effect into account? And sometimes you'll need to talk about the placebo effect. And if not, why is this important? Or even if they did, why is this important? Well, it didn't, obviously, since the women knew whether they were receiving the ultrasounds or not. What might happen is they might behave differently than those who didn't receive ultrasounds simply because they knew they were getting the ultrasounds, right? And it could go either way, right? They knew they were getting ultrasounds. They knew that the experiment was testing to see if ultrasounds created heavier babies. And so maybe they really watched what they ate to try to keep the baby from gaining too much weight, or it could go the other way. Maybe they knew they were getting ultrasounds and were told that the experimenters believed that the ultrasound was creating bigger babies, and so they thought, you know what, it's going to happen, so I'm just going to eat what I want and let the baby do what it's going to do. So, you know, or even try to make a baby, you know, gain more weight than it would have otherwise. I don't know, but we're human, and so we're going to behave differently once we know that something is being done. Was the experiment double blind, right? In other words, did the subjects and the people measuring the response not know who's getting the treatment? The answer to that is no, it wasn't double blind. The women and the doctors, the mothers and the doctors who were measuring the babies would have to be unaware of which treatment the women were receiving. And so while the doctors who were measuring the baby might not have known, and they probably didn't, and that would be ideal, right? Not that they would be able to skew the results, obviously. You can't weigh a baby differently. But the women, at least in this setup, certainly did know. So, and again, why is this important? Because, you know, the mothers, again, knowing which treatment they were getting, could have tried to influence the outcome one way or the other. And so based on your answers to number 1 and number 2, how would you improve the design? And you might have a couple of different ideas. One thing that I thought was You could set it up so the mothers couldn't tell whether they were getting an ultrasound or not. So something like set up a sheet so the mother couldn't see what was being done. And then, even using the ultrasound wand, either with the machine on or the machine off, to know if they were actually receiving an ultrasound or not. Could be a way to set it up so that the mothers were blinded as to which treatment they were receiving. Okay? And that's important. It's important that we make sure that's the case, especially with human subjects where we're so prone, whether we really want to or not, to react differently knowing what we're getting into. So there you go. So we want to make sure that we're double blinding our experiments whenever possible. And so what we're looking for is a difference, when we set up an experiment, is a difference in the response, in the responses between our groups, right? We can create this comparison group, and we want to see a difference in the response to our two different treatments, whether it's a control group with an inactive treatment or just two different treatments. We want to see a difference in the response between our two groups. That's great if we do, but the question in terms of trying to establish this cause and effect relationship was that difference so large that it could not have happened just by random chance? Now, what does that mean? Well, it means that even though we're going to randomly assign our subjects to two different groups, it is still within the realm of possibility that we create two groups that are different in some systematic way that might drive the results other than the treatment just by random chance. I mean, no bias is involved. It's just what could happen even with a random assignment. And so, again, we talked about this with the Coke versus Pepsi experiment. We're going to use the laws of probability, which describe chance behavior, and we'll talk a lot more about that when we get to chapters 5 and 6, to learn whether the treatment effects are larger than we would expect to see if only chance were operating. If they are, then we talk about statistically significant results. And I know we discussed this a lot with the Coke versus Pepsi, but this is the driving force behind what we do in statistics. We want to establish significance when we can, okay? And so there's a definition here for you for statistically significant. We'll talk about this so much through this class. But if we observe an effect so large that it would rarely occur by chance, then our results are statistically significant. A statistically significant association in data from a well-designed experiment does imply causation. And so there's your causation, right? In a well-designed experiment and an association that is deemed statistically significant, then we can have our causation that we're looking for. This causes this, right? And so to talk a little bit about that, we get into an activity, which is your next slide here, that talks about whether you're talking to a passenger in your car or using a cell phone, which two situations might cause you to be more distracted in the car. And so we'll take a look at this in class tomorrow. We'll open up class with this activity, do this pretty quickly, and then get to the few homework problems that we have. So that's it. I don't want to get into blocking just yet. That's your next slide. We get into blocking and matched pairs, which are a couple of different experiment designs. It's going to take a little bit longer to go through those and a couple of examples. So we'll leave off at that. We'll pick up probably tomorrow night for the rest of these slides and really start working our way towards our first test. So a little short tonight, so enjoy yourselves, and we'll see you guys tomorrow.